Lo grabo aquí para que quede. Okay. Here is the problem. Yeah. Released in 2018 is no calculator allowed. No, it's calculator allowed. Yes. Right. And well, says is people enter a line for an escalator at a rate modeled by the function r given by this piecewise function. So between 0 and 300 is 44 t over 100 cubed, 1 minus t over 300 up to the 7. So it's a crazy polynomial. And after that, 4 times more than 300, there's 0. So the rate of change is 0. So 0 people per time, where r is measured in people per second and t is measured in seconds. As people get on the escalator, the exit line, and they exit the line at a constant rate of 0.7 person per second. There are 20 people in the line at time t equals 0. Okay. So, and the first question is, how many people enter the line for the escalator? Here's the first question. During the interval 0, 300. So how many people enter the line of the escalator? Let me just write this problem right here. There's r of t. This is 44 t over 100 cube parentheses 1 minus t 300 to the 7, 0. This is 0 less or equal than t less or equal than 300 and 4 more than 300, correct? So this is the problem right here. And of course, the units of r of t are people per second, right? So this is the derivative of something that we are going to name P. P is the number of people, right? Number of persons per time. So because these units are people per time, so this is dPdt, correct? It's immediately what you have to pretty much catch when you read the problem, correct? Now, the situation the problem explains is when you have an escalator right here. This is the escalator. Let's suppose it's a triangle. So you enter people here, and then you drop out people here. So this is the rate the people enters per second, correct? And the let me just say dq dt, where is the people the rate the people leaves the escalator is 0.7 people or persons per second, is what says the here, right? Integration differentiation. Let me see right here. So right here. Let me just look right here. Yeah. Per second, correct? Person is person. I just put person. Person. Okay. Now you enter at this rate, you leave at this rate, and you have 20 people at time equals 0. So there were people lined up here in the escalator at the beginning of this thing. So they were 20 at T0. Okay, so you visualize the problem. So you enter people is right here, and then enters and leave, correct? Okay, let's find the first question. So the first question is, how many people, right, enter the line for the escalator in the 0 to 300? So I have to do P300 minus P of 0. What I mean, the P of 0 is no count because it's people already in the escalator. So let me see, they put it right here. P0 equals 20. Then this is the function that models how many people enter the escalator. So it's just the difference between what I get from here minus the 20 that were in those, was because all these were already in the escalator by time 0. So I have to get this one. So remember, R is, or R of t, is dp dt, correct? I told you. By the units is the derivative of the function number of persons divided by time, correct? Now, I need to find P. So this is what I need to find. So what I have to do is, well, I'm going to multiply times dt, so it's R of t equals dp dt, correct? Oh, R of t dt, right? And then this is going to be the differential of P. So I have d of P equals R of t dt. Now, how do you remove the differential? Well, with the integral. So you have to integrate this one from P0 to P300. And this is going to be from 0 to 300. So the time, remember the time goes from 0 to 300. So you're going to have P in 300 and P in 0, correct? Well, this is not a problem. So this is going to be P300. Well, let me just put it right here down. Okay. P300 minus P of 0 is the integral from 0 to 300 of what? This thing right here. So you can write it you want. 44 times T over 100 cube, parentheses, 1 minus T over 300 to the 7 dt. Okay? Okay? So that's what we have right there. Yeah. Okay, so, well, in this case, we're going to need a calculator, of course. Oh, let me see. Okay, let me just get this one share right here. Oh my gosh. Well, let me see. I'm going to open the calculator. Well, so everybody catch the idea, right? Right here. So this is the function that models the people entering in the escalator. And then you need how many people enter the escalator during these 300 seconds, right? Oh, yeah, 300 seconds. Yeah, 100 seconds, right? And, well, you know how many people were in the escalator at the beginning of the process. That's 20, so we don't count them. So we have P of 300 minus P of 0, right? Just get this one right here. And, well, we know that R, the function R, is a rate. Well, it's the rate of change of people over time. So it's the PDT. Then we solve for P. We have to integrate. We get this difference. That is what we are going to find. And we have to put this in a calculator. So let me just go back to this portion. So let me share screen. Yep, right here. Share screen. Here is the calculator. And, well, we open a new document, a calculator page, and then remember, where is this thing? So this is menu, calculus, integral, and then we put here 0. We put here 0, here 300. And then here we say, well, let me see if I have to do, well, let me just, before that one, before this one, let me just press enter. Let me see. Okay. So before this, let me just define the function because I don't want to type this too much or too many times. Define. Yep. Space. So I'm going to put R of, in this case, X, right? Equals. And I'm going to type this only once, so it's 44 times parentheses X divided by 300, yeah, to the cubed, then times 1 in parentheses 1 minus t, 1 minus x over 300. Yep. And then this to the 7. Correct. So with this one, save time because we just type this one. So press enter. And the calculator tell me, yes, I have the function r, and it's pretty much the same. Yeah. Now I'm going to do my calculus menu, calculus, integral. Then I have from 0 to 300. Yep. And then here only I have to use r parentheses x, and here the x. So I don't have to type this again. And if I have to use the integral again, I just get this one. So press enter. And then we are going to see that we got 10. So in the lapse of time of 300 seconds, only 10 people enter the escalator. Okay. So in my paper, I'm going to put here 10 persons. Correct? 10 persons. Okay. Any question to this point, or is clear? Yep. Not a big deal. Pretty much the things we have been doing.
Yep.
Okay. Let me see the next question. So I'm going to now read the problem. So it said during the time interval 0-300 seconds, right? There are always people in line for the escalator. How many people are in line at time t is 300? Let me see. Here is here, right? Let me see. I said during the time 0-300, there are always people in line for the escalator. How many people are in line at time 300? This is, well, let's see. In line for the escalator. It will enter a line for an escalator at the rate model by the function this, where this measure people seconds. As people get on the escalator, they exit the line at constant 27. Okay. Okay, let's see this one. Any idea how to solve this one according to the information we have? No? A ver, read the problem. So that's why this problem was very, very discussed after the test. So you understand what is, you understood this question, the first one, we did it. What about the second one? There are always people in line for the escalator. How many people are in line at time 300? What do you think?
¿Qué no sería 10 más 20?
You think? Why?
Because that's the people that entered plus the ones that were there. Oh, wait, no, wouldn't it just be 10?
Okay, this is the problem with this, the English. Is during the time 0-300, there are always people in line for the escalator. How many people are in line at time 300? So the first question is how many people enter the line? This is the function enter the line, correct?
Yeah.
So we did this one. It says, okay, well, enter the line. So, well, this is the one. So, let me see, this is measured people second, is measured in seconds. People get in the escalator. They exit the line at a constant rate of 0.7 per second. There are 20 people in line at time 0. Yep. So there are 20 people in line at time 0. Okay, well, in line, not really on the sky, but in line. Okay. How many people are in line about time 300? Okay, let's see. The first problem Let me just put it right here. So was P300 minus P in 0 equals 10, correct? So this is what we solve in the first problem, right? P300 minus P in 0 is 10. So this was 20, correct? And this is P in 300. So P of 300 was 30, correct? So if I solve this one, this is okay. How many people entered the line? Well, on the line at the 300, they were 30 people there. Everybody catch this reasoning? This is the people that entered the line in the 300 seconds, 10. They were 20 already there. So enter minus the 20 they were really 10 entering. But if you says, okay, how many people were in the line really at the 300 seconds? Well, you have to put these ones also because these were already in the line. So you put 20 plus 30, 300, correct? Now, once, okay, this is okay. These were all the people entering the line of people on the line of 30, but there is something important. As the process began, right, people was entering the escalator, so the rate was what? Okay, the rate was Q of R equals negative 0.7 people per second, right? Or persons per second. So these 30, right, are all the people in line that were on the line in 300 seconds, but by the end of the 30 seconds, some of these people were entering at this rate. So I have to subtract something here, correct? What I have to subtract? What do you think? So everybody's following the reasoning? Yeah? So let me just put the line for the escalator again. This is the escalator. So they were really 10 people, no, 20 people right here already at t equals 0. Then they were arriving at this rate more people right here. Yes, but after the t0, there were entering here a 0.7 persons per second, correct? Yep. So this subtract this number. And at the end of the 300, you have certain number of people here that enter that subtract to these ones we have here, to this 30. Really? During the 300, there were 30 people here. Then how many people entered during the time? This is, well, let me check that. So it's Q of time, right? Q of time is, let me see, the people that, no, let me just put it here. How do I represent this one? Getting the escalators. Well, I need to represent this 0.7 something. So R, P, R, what letter I can use? Okay, let me just use the E of T. People entering, the rate of entering is the capital Q dt. This is the people that enters the escalator in the constant of time. This is 0.7, correct? Now, if we integrate, this is dq dt equals the integral 0.7 dt, right? Like that. So I have from q in 0 to q to 300, right? This is the number of people enter, right? Is the integral from 0 to 300, 0.7 dt. Now this is delta q, so q 300 minus q of 0. This is 0 because nobody was in the escalator really. This is 0.7 t from 0 to 300, correct? So then, so q 300, the number of people enter was 0.7 times 300. 300 minus 0. Let me just put it complete. 300 minus 0, and that's equals to what? 21, correct? So, if you subtract this 21 from this 30, right? This is 31, right? No, 21. This is 21, and here you have 30. How many people are at the line at the end of the 300th? How many people? So in the 300, you have 30 people here. During those 300, you move 21. How many you have at the end?
9.
Correct. So you have R 300 minus Q 300 is 30 minus 21, 9.
Oh, okay.
Yeah. See, yeah, this problem is kind of weird, correct? Yeah. So is everybody understanding the reasoning? Yeah. What happened? Okay.
Vamos a hacer otra.
Vamos a hacer la otra, correcto. You're right. Okay, next question. For t's greater than 300, what is the first time there are no people in line for the escalator? Okay. So for t more than 100, okay, you have here, let me just go back to this one. So 9 people at the end of the 300th. Now, these 9 are going to enter again at 0.7. So in how much time you left 0 people here? Because after the 300, no more people is entering because this function is 0. Oh, let me just put it here. Less than 300. T greater than 300, correct? Well, this really is this one and this is more. Okay, so there is no people entering at the escalator after 300. Okay, so you have 9 here. In how much time you have 0? If you enter at the rate of 0.7 person per second. Everybody understand the question? A ver, ese es basic. A ver, Brandon, usted que es ingeniero.
9 dividido por 0.7.
9 dividido por 0.7, you think?
Yeah, a ver,
So what's it the reasoning? What is your reasoning?
To see how many
Why
times
multiply by 0.7?
To see how many times 0.7 fits into 9, so you know how many seconds it was.
Okay.
How many people are going in?
What is it?
Like 0.7, that's how many people enter, not leave, right?
For example, a ver, this is what was more not criticized but observed. You enter at 0.7 persons per second. This is how you split the people or what you do, correct? Yeah. So this is point. In 10 seconds, how many people enter? How many persons enter?
7.
7, correct? If you have 9, it's going to take more than 10 seconds to empty the line, correct? You see? Entonces, in some way, let me see. You enter 0.7 per second, so in 10 seconds, enter 7. So how many seconds you need to use to get the other 2 in? Pretty much.
The other 2?
The other 2. Because in 10 seconds, you took 7 from here. They are here in the escalator. You have 2 in line.
Okay.
How much time do you need to put these 2 inside?
A little bit less than 3 seconds.
A little bit less than 3 seconds. How do you get that exact number? Ya lo tienes, Brandon. You have it.
Pues ese es 13 dividido por 0.7. 3 dividido en tu 0.7.
A ver, déjame ver. You told me first 9 divided by 0.7, correct?
Uh-huh.
Okay. How much is this?
I don't know.
It's not very difficult to know it, right? So 0.7 over 9. So what is that? 1, 1. You have 1, correct? You have 2. You have 2. How much is this? 2. Then you have 6. No, 14, right? You have 6. Pretty much what is that? 7? No, 8, correct?
Mm-hmm.
Is that consistent with your reasoning? You said a little bit more than 2 seconds or a little less than 3 seconds. Is that consistent?
Yeah, porque es 2.8.
2.8, correct. Okay, your reasoning was correct. So what is this? Yeah, how can we justify this reasoning? So how do you justify this number? Now here comes the difficult part, Randall. So the number is correct, but you have to justify why you divided 9 by 0.7. How your brain conclude this one?
I did 9 over 0.7 to see how many times how many seconds it would take for 0.7 persons per second to be 9 people.
Okay, so you are talking about a question like this, right?
Mm-hmm.
Okay, so here dt is delta p over 0.7, correct? Now delta p is the number of persons entered. This is the 9, correct? Delta t is 9 over 0.7. You like the reasoning? Rangel, you like the reasoning?
Yeah.
It's clear? Yeah?
Yeah.
Okay, well, let's move on to the last question. Yep, right here. For the interval 0-300 seconds, at what time t is the number of people in line a minimum? Oops. To the nearest whole number, find the number of people in line at this time. Justify your answers. Oh my gosh. Okay, let's see. So, line a minimum. Okay, number of people, right? So this is the rate the people arrive to the line, correct? This is, I put E of t, the rate the people leaves, right? Yeah, the line from t, what? So I guess it's for always or for t positive, right? Because this is the rate they enter to the line, correct? So how can we know that? Yeah. And this is the portion that is for thinking. Let me see. What is the problem? I lost the page. It's right here, correct? So it's like one of those equations in physics you know as conservation. So suppose you have here a little cube, right? Yep, is the thing. So this is people entering, this is people out, and this is people inside, correct? In, out, inside, correct? So how do you find the people inside?
Cuéntalos.
You know this, you know this. How you know it?
With the equation.
Ajá, pero ¿cómo? Yeah. You know that there were 20 at the beginning, correct?
Mm-hmm.
Yeah, in the line, right? Then you have people in and then people out. So you have 20 plus the people in minus the people out is the people in the line, correct? In line, correct?
Yeah.
Online. O on the line. Enter line. No, no es como lo ponemos. Inside. Vamos a poner aquí inside the line, correct? So everybody understand this reasoning? So you have 20. You add these people, and then you remove these people. This is the total number of people entering the slide, right? correct? Okay, you need to find the mean of this person. So how do you find that?
Double derivative.
Ajá. The derivative, vamos a ver. I have 20 plus RT minus ET, right? Equals, well, not really. This is an integral right here. I have these integrals, right? The number of people, right?
Oh, yeah.
It's 20, the number of people. This is the rates of change, correct? So I need this number. So 0t, 0t, and this is the number of people, right? Inside. It's the number of people, n. Let me just put the n of t, correct? So, Random told me the derivative of this. So if you take the derivative of this, so dn dt equals 0. So dn dt is this derivative. So the derivative of the 20 is 0. And then you have RT minus ET, correct? Now, I have to find in this interval minus 7. So I have 44. Oh, vamos a ponerle aquí. R of t minus 0.7 equals 0. So how do you solve this one? Well, it's R of t equals 0.7. So what I have really to solve is 44 t cubed times 1 minus t over 300, 7 equals 0.7. Okay, that's an easy equation to solve. Of course, you have a calculator, correct? Everybody remember how to solve this equation with a calculator?
No, numerical solve.
Numerical solve, perfect. So let me just go to the screen, right here. And well, you can do this graphically if you want, or you can do this numerically, con numerical solve. So let's suppose I want this graph. Let me just think like that, correct? So I put here a graph, yeah, and then I put here R of X, right? And I get my function, oops, right? Obviously, I have to adjust the window, menu, window zoom, window settings. This runs to 300. I'm going to put here 300. Yep. And I'm going to move this to, let me just put here a 20 or 30. That was the numbers I had, 30, right? Enter. Oh, what happened here? It's not. Oh, yeah, it's 44. So I put here Control G, let me see, Control G. This one. Okay, this is a rate of change, but I forgot to, let me just check this one. Up, out of X, yeah, out of X. So I don't see any movement right here. I see this flat line. Why? Let me see. I should see something more. Yeah. 44.
Just define it again, Ramirez.
You think?
Maybe.
No, pero hasta aquí is 44. X, yeah, I got here a 10, correct? What sounds reasonable. Entonces, ¿por qué no me deja? 44. Well, I don't know. This looks strange. Because my idea was to make this equal 0.7. So 0.7 is right here. I don't see an intersection really. So this is strange for me. Let me see. Okay, let me just do the number solve right here. This is algebra, numerical solve. And the thing is, you put the equation, so we are going to put R of X R parentheses X, and here equals 0.7, 0.7, oh, 0.7, 0.7, right here, 7, and comma, X. I'm going to solve for X. And technically, if I press here, I need to find something. No solution found. That's a big deal. Because 0.7 R of t, enter 44, yeah. No solution found. Oh, let me see. Let me just go back to the problem again, because this is weird. Here it is. So what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. So let me just see here. I have 20. Let me just go back to my screen right here. This is my reasoning. I have 20 people in the line, then in people, out people after the T0. So 20 minus plus the people in minus the people out is the people in the line, correct? So it's 20. This is people in, is the integral from 0 to 300 of t. This is 0 to t. And this is an n of t. This is the number of people in the line. So this one with the time. So we take the derivative, the n dt. So this is a 0. This is r minus et, correct? According with this is rt equals 7. So rt equals 0.7. And this is plus 44.7. And I graph this thing in the calculator, right? R of x is this one, 44, x, 1 minus 300. I don't see any situation strange. Yeah, it's obvious that there is no solution because this is 4400. Yeah. Let me see. Control T. Yeah. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. 20, 30, 27, 29, 30. It's 22 always. 0.7. Oh, no. Let me see. 0.7. Yeah, no, it's 0.7. Yeah, this is the rate. Yeah, never reach something more than, but the area here is fine. There is a minimum. I don't understand the reasoning here now. Okay, well, possibly what we have to do is take a little bit more time for check this one, right? Right here to the nearest whole. Well, I need to check this one a little bit more.
Okay.
So I don't know. Technically, the reasoning looks fine. I don't know why this is not entering here. Okay, well, let me just then move to another problem. Yeah, we did 3. I'm going to check this later and tell you tomorrow what happened. Okay?
Mr. Mears,
Yes, sir. Yes, sir.
I have a class at 1, so I'm gonna go eat right now.
Okay, go ahead.
All right. See you tomorrow.
See you tomorrow. Okay, let's do this one here. Oh, this is one that is a table and a graph here. So let me just at least do a couple of them, right? And then go to the next one. Okay. So this said, let f be the function defined by f of x equals cosine 2x plus e to the sine x. Okay, this is calculator allowed by sure. Yeah, no calculator. Wow. Okay. Let g be a differentiable function. The table O gives values of g and its derivative g prime. Correct. At selected values of x. Okay, you have x, g prime. Okay. And this is the graph of h. This is, let h be the function whose graph consisting of 5 line segments is shown in the figure above. Okay, we have this shape right here. Question. First question. Find the slope of the line tangent to the graph of f at x equals pi. Okay, that's not a big deal. F of x is cosine of 2x plus e to the sine x. And I want the slope of the tangent line, so I have y minus y0 equals mx minus x0, right? Let me just go right here. Yeah, this one. Yep.
Yeah.
At the point, is find the slope of the tangent line of the graph at x equals pi. Yeah, when x0 equals pi. Yeah, so I need to find this one when the x is pi. That's okay. Well, is for yeah, f. So x equals x0, yeah, x0 equals pi. So y0 is the function in x0. So I have to evaluate this thing. So it's cosine of 2 pi plus e sine of pi. Oops. Cosine of 2 pi, what is that? Nothing, something? No calculator.
Es cero, ¿no?
A ver, vamos a recordar la gráfica. This is cosine of 0 is 1, pi over 2, 0, negative 1 in pi, 3 pi over 2, this is 2 pi. So what is the value?
1.
1. Sine of pi, sine of pi, remember, pi over 2, sine of pi, 3 pi over 2,
Yep.
2 pi. So what is going to be?
Cero, ¿no?
0. So it's e to the 0. So it's 1 plus e to the 0. 1 plus 1 is 2, correct? Then, so for y equals 0, y equals 1. Now I need the slope. Okay. M is f prime in x0. So I have to find the derivative and then evaluate it in pi. Okay, what is cosine? What is f prime of x? So k prime of x is the derivative of cosine, negative sine of 2x times 2 plus the exponential e to the sine x times the derivative of the sine cosine x, correct? There is. Now I have to evaluate in pi. F prime of pi, so it's negative sine of 2 pi times 2 plus e to the sine of pi times cosine of pi. So what is that equals to? Sine of 2 pi, I see here. Sine of 2 pi is 0.
Viene cero.
So this is 0 times 2 plus e to the sine is 0. Okay. 1 times cosine of pi. Cosine of pi was that?
Or negative 1, negative 1.
Negative 1. Negative 1. So I have 0 times 2 times plus 1 times negative 1. So this is negative 1. So my slope is 1. So my line is going to be simply y minus 2 equals negative 1 parentheses x minus pi. Here is my solution. Okay. Okie dokie. One more screen right here. So this is let k be the function defined by h of f of x. Oops, h of f of x. Find k prime of pi. Okay, let's do that. So this is k of x is h of f of x, correct? You need to find k prime of pi. Well, let's see. That's not difficult to solve. So this is a new function, right? K of x, k prime of pi is what we need. Okay, let's find k prime of x. K prime of x is derivative of this h prime of f of x times f prime of x, correct? Now, k prime of pi is h prime of f of pi times f prime in pi. Okay, now, f prime in pi is the one we solved before. What is that? You have it right. Is the slope of the tangent line, correct? That was -1. -1. And what is f prime of pi? You remember? No? So these values were in the previous problem. So I erased them. So you have it on your paper. So what is this? -1, I remember. And this? Nothing? No?
Is it 0?
No. It's this function in pi. Cosine of pi, remember, is 1. And this was sine of pi, a to the 0.
Oh, it's 2.
2, correct? Okay. So this is negative h prime in 2, correct? Now, who's h prime? Okay, let me just go back to the problem. Okay, right here. This is h. Okay? H prime in 2. Here is the 2, right here. Okay? What is h prime in 2? H prime is the slope of the tangent line in 2. So what is that slope?
One-third.
Positive or negative?
Negative.
Okay. So on my paper, I'm going to do negative, because it's negative at the front. H prime in 2 is -1/3, so negative times a negative positive, that's a 1/3. Okay? Questions here? Not difficult?
No,
That you use here, composite functions. So this is a composite function. You need a derivative on this value of the composite function. So I get the derivative of the composite function. With the exchange rule, I get this one, right? Not a big deal. Then I put the pi. So I need f of pi, f prime of pi. So this in pi, I found that was a 2 because that's the y of x equals pi. And this is -1. That was the slope of this one. So I just multiply. Negative times a positive negative is h prime in 2. Well, right here, I see the slope in the graph. So this is 2. Okay, the slope of the tangent line is as double this line. This is 1 rise over run. -1/3, -1/3. So 1/3. Okay. Not a big deal. Okay, let's do the next one. I'm finished today. Let's see. Yeah.
Ya tenemos otra clase, Ramírez.
¿Ya tienen que ir?
Pues tenemos clase a la 1.
Ok, pues entonces paramos aquí.
Sí.
Yeah. And